Welcome to the second video of the series uFocus HMI Improving Graphics. No idea what we're talking about? Then watch your introduction to HMI first. In this video, we'll show you how to improve symbols used in process graphics. Process graphics often contain many symbols, such as valves, pumps, heat exchangers, and vessels or other units. In our projects, we've come across a chaos of symbols, facilitated by multiple graphical features of HMIs. Does this help the operator to do his job? Probably not. On the contrary, it may lead to confusion, loss of overview, wrong symbol interpretation, and maybe safety risks. Remember our ground rule, always keep it simple. In this video, we'll show you how we apply this rule to these 4 frequently used symbols. So let's have a look at the symbol which represents a heat exchanger. Heat exchangers are often represented literally to the construction instead of the function. This function of transferring heat between 2 pipelines can often be represented simple and small. Let's try. First, we get rid of the added details. Then we replace the 3D representation for a simple form. Don't add borders. These are unnecessary since the color of the symbol has sufficient contrast to the background color. The color gray is chosen for the symbol and process lines to keep the visual load to a minimum. After all, this symbol is static information, which means that the operator knows its meaning and it doesn't need emphasis. We use a basic square shape as opposed to round shapes which are used for motorized symbols such as pumps. This same basic square shape can also be used for a filter symbol and other static objects. To indicate that this basic shape is exchanging heat, we use the commonly used heat exchange symbol. This new simple representation also complies to the guidelines we discussed in our first video about pipelines. The main process flows preferably from left to right and from top to bottom. And we want to avoid crossing lines and right angles and curves in the pipelines. Here is another way of presenting a heat exchanger, in which the secondary flow goes in and out on the same side of the symbol. Depending on the layout of your process graphic, you can choose which one you want to use. Our improved heat exchanger can now be placed into a graphic. In this example, the process lines also have a 3D representation. Let's apply the simple guideline to all the process lines in this graphic. Next, we'll have a look at the common representation of a valve. Note the mushroom or head on top of the valve. The head doesn't add any useful information and can therefore be discarded. Valves are placed in process lines. For an open valve, consider coloring the valve symbol exactly the same as the piping, thus emphasizing that fluids or gases are running through the valve. Closed valves can be presented by a symbol with no fill. Do you need a bar graph? Don't add a scale indication. A bar graph is used for quick reference, and a scale indication causes a crowded impression. If more precise information is needed, then presenting the process value is more suitable and the bar graph can be omitted. A value near a valve indicates in most cases the percentage of opening. Just showing the value without a percentage is sufficient. Putting a percentage below the valve indicates that it is a controlled valve. When a clear distinction between types of valves is necessary for the understanding of the operator, we can add additional elements, such as shown here. Let's replace the valves from the example graphic with our improved valves. The third symbol we want to clean up is a pump. First, we remove all accessories without a meaning from the symbol. Exactly, what remains is just a circle. A circle indicates a rotating element, so we will keep this part for the base of our pump symbol. Again, we pick a color with just enough contrast with the background. Do not use strokes, the symbol stands out from itself. because there will be more symbols indicating rotating elements, we need a clear distinction mark, such as an arrow. An arrow also provides an indication of the flow direction. Next, we align the process lines so there is a continuous straight flow, making the graphic and process flows easier to interpret. We can place our improved pump in our example graphic. The final symbol we discuss in this video is a vessel. Let's try to apply our guidelines to this symbol. A vessel symbol is perfect for grouping information. For example, process values measured within the vessel can be depicted inside the symbol. Also, other internals, such as heat exchangers, agitators or sprinklers, can be added inside the symbol. In this way, instead of having all separate items, it's connected to the symbol it refers to. The internals can be static, for example heat exchangers or separators, or dynamic to indicate their status, such as agitators or sprinklers. Static internals should only be added to indicate meaningful differences between the vessels. It is unnecessary to depict the actual internals in detail. The representation of the vessel is just to indicate it is a vessel which can group information. It doesn't need emphasis or 3D effects. A gray rectangular shape which represents the vessel is sufficient. The actual size of the vessel is not relevant for its representation. Choose a maximum of 2 to 3 different vessel sizes to use in your graphics. The size of its representation should be in balance with the information that the vessel contains. In this example, the level bar has a modest appearance. However, we've come across representations in which the vessel itself functions as a level bar, rendering the vessel with bright colors, making it difficult to read the actual process value or detect alarms. This level bar can be improved a little by removing the 3D effect. The height of the level bar should be in balance with how much space it claims in the symbol and how detailed the level of information needs to be for the operator. The process value, which refers to the bar graph, can be placed on the left side of the bar graph. Other values are placed above. By removing the frame around the process values, the graphic has less visual load. The exact position of the different elements inside the vessel is not fixed. Just be sure all your vessels in the system have the same layout. In this example, we have one internal element, a heat exchanger. We just made a symbol for that. We use the same symbol here. Representations in graphics do not need to be the exact replica of the reality in the plant. The operator just needs to know that this vessel is heated. We can now replace the vessels in the graphic. This video showed how symbols can be improved by applying a few general guidelines. These improved symbols make the important information stand out more. All the unnecessary parts have been removed. Looking at our graphic, there are still a few improvements possible. Want to know which ones? Have a look at our first video about pipelines. Still remember those rules from the first video? Try to apply them to your own graphics. Of course, you can always send us your example for a quick scan and feedback. We can also help you with workshops, and of course we are specialized to help with your HMI design projects. Do you want to learn more about improving graphics? Then watch the other videos in the series uFocus HMI Improving Graphics. Don't forget to like this video and subscribe to be the first to know about our new releases.